In this video we will look at some inexpensive but safe ways to observe the sun. We will not consider specialist kits such as hydrogen alpha filters that are used by experienced observers. Our focus here is primarily on what is appropriate to the beginning amateur astronomer. Firstly, we should understand the dangers of solar observation. There are three of them. The first of these is heat. Perhaps surprisingly, the main hazard to the solar observer from heat is not eye damage, but fires. Whenever the sun's unfiltered rays are focused, there is a potential fire hazard. Always ensure that you are in full control of any optical equipment so that this cannot occur. The second is photokeratitis. This is the burning of the cornea. You may know it either as snow blindness or welder's flash. This form of damage is relatively rare in solar observers. The third hazard from solar observation is photochemical retinopathy. Most people have never heard of this, but it is the one that is most likely to cause eye injury. It is caused by ultraviolet, specifically UVB, radiation. The UVA is absorbed by the cornea, where it causes photokeratitis. Photochemical injury is painless, but it can cause full or partial blindness. It is usually temporary, typically lasting 2 months to 1 year, but it can be permanent. The most likely cause of photochemical retinopathy is the failure or improper use of a solar filter. For this reason, many people consider projection of the sun's rays onto a screen to be the safest solar observing method. We'll now look at how we do this. This is a very simple projection system being used at the eclipse of 1999, August the 11th. It consists of a sheet of white paper clipped to a square of plywood that is held in place by a length of aluminium angle. The other end of the aluminium is attached to the tube of the telescope with a pipe clip, also known as a Jubilee clip. The device is adjusted by bending the aluminium. Simple but effective. The image of the sun is focused onto the screen. I prefer to use inexpensive eyepieces for this. The one here is a 20mm Huygens. There is a circular card mask on the telescope tube. This not only keeps the projection screen in the shade, but also prevents the small finder scope from receiving direct sunlight. Remember what we said about controlling potential focuses of heat. The small cloth draped over it prevents any light leakage between the telescope tube and the mask. This was just degrading the image. It's very simple indeed, but very effective. The image is easy to view. In fact, many people commented that the image from this was the best from any of the dozens of projection setups in the field. The main hazard is that someone could attempt to look into the eyepiece. The aluminium angle makes this very difficult to do, but there should always be a responsible, vigilant person in attendance with any projection setup to ensure that this cannot happen. In an emergency, merely shift the telescope so that it is not pointing at the sun. The basic design can be improved. This device is a projection box. It is made from lightweight foam board and is held together with gaffer tape. Because stray light is better controlled, the sun's image is much more contrasty than with a simple setup. However, it is not as amenable to group observation. Here is a photograph of a sunspot taken with this setup. Just take a photograph of the screen through the observing hatch in the side of the box. Your finder scope will not be shaded with this setup, so remember to cap it at the big end. Solar filters, with one exception that we will examine later, are entirely safe if they are used properly. However, there are two caveats. Firstly, only ever use materials specifically designed for solar observation, and use them only in accordance with the manufacturer's instructions. Secondly, because even a pinhole can let in sufficient light to cause photochemical retinopathy, any form of solar filter must be checked by a competent person every single time it is used. The simplest incarnation of these is probably what has come to be known as the eclipse shade. These are spectacles with a filtration film as the lenses. There are, of course, no actual lenses. You should never use an enclosed Cassegrain type telescope, such as the common Schmidt-Cassegrain and Gregory-Maksutovs, for projection of the sun, because of the likelihood of damage from the heat build-up inside the telescope. Filtration is therefore your only option. You should obtain your solar filter from a good, reputable astronomical retailer. I make my own from a substance called Baader Astro Solar Safety Film. This is available as an A4 sheet and comes with full instructions of how to make and use the filter. Do not deviate from these. The filter fits over the big end of the telescope. Never use a filter at the eyepiece end. This is the exception that I mentioned previously, but more on this later. You can also use them with binoculars. If so, tape them on with masking tape, because the way binoculars are used, there is more likelihood of the filter slipping off than there is on a mounted telescope. You should ensure still that the filter is secure. On one telescope that had little lugs on the side, I cut L-shaped slots in the filter so that it made a sort of safety bayonet connection system. This really is the best option for simple solar photography. Here is a spotty sun, and here is a bit of detail. And now that exception I warned you about. Never use eyepiece solar filters. This is an eyepiece solar filter. It fits either into the eyepiece or into the diagonal of the telescope. And this is what can happen to it in use. This puts your eye at risk. There is a companion video to this one on my YouTube channel, and you can see on that video exactly how this happened. Have a look at it, and never, ever take that chance. Solar observing is rewarding and can be done safely if you remember these 5 simple rules. 1. Use only projection or a big end filter to observe the sun. Never use eyepiece filters. 2. Use filters only in accordance with the manufacturer's instructions. 3. Thoroughly check your solar observing kit every time you use it. 4. Never leave a telescope unattended if it is pointing or could point at the sun. 5. Cap your finder scope. If you don't, sooner or later you will find out why you should have done. Remember that solar safety is everybody's responsibility. It's up to you to ensure that your system is safe. Don't take chances, and double check any advice you're given, including mine. Thank you for watching.